Hi and welcome to video 6, Unit 4, Topic 1, Math Methods Curriculum, and we're looking at optimization. This is our second example in video 6 of area and volume type questions. So here we go. Now this is a heavily scaffolded example, but it does get a little bit complex, so it could be a complex familiar, probably a harder simple familiar question. A rectangular prism container with a base length twice its width is to be made with 48 meters squared of metal. Now we've got a show that question, which is the link, and then B, express the volume in terms of X, in which case we're probably eliminating H, and then find the maximum volume. So let's start with step 1, which is to get our head into the question, and to do that I'm going to draw this prism. So I start with my rectangle on the front, I draw the same rectangle on the back, it's going to look like this, and I'll just dot it like this. There we go, and then I'll connect up all those matching vertices. Okay, so there's my rectangular prism. Now what are we told about this? We're told that X is the width there, and we're told that H is the height, or I'm going to assume that H is the height. Yeah, there we go, the height H is that. And we're also told that it has a base length of twice its width. So let's call this 2x. So now I know a couple of things, and because this is scaffolded, I can't naturally follow that step 1, 2, 3, 4, 5, 6 that I've been setting up. But in step 2, I might just take the time to define my variables. So I've already got x equals the width, and notice here that this is in meters squared, so we'll do width in meters. H equals height, also in meters. And then I've got SA equals the surface area, and that's equal to 48. And we've got volume, which is what we're trying to maximize. Here in part C, volume, and this is in meters cubed. That's in meters squared. Okay, so if the surface area equals 48 meters squared, hopefully you can see here that this surface area, I'm going to go over and just pop this out over here. The surface area is going to be equal to 2x times x times 2. So this is 2x times x, which is basically the base here, but there's two of them because there's a top as well. That's the first part. Plus 2x times h times 2. So this is 2x times h is this front face here, but there's also the one in the back. So there's two of them, and then plus x times h times 2, and this is because this side here is x times h, but we have another side here, so we get x times h times 2. And if I simplify this, I get 4x squared plus 4xh plus 2xh, which is 4x squared plus 6xh. Now we know the surface area is equal to 48, so let me write this down as 4x squared plus 6xh equals 48. That's given in the question, which means that 6xh is equal to 48 minus 4x squared, and that means that h is equal to 48 minus 4x squared over 6x. Now I knew to go there because it's given me something to find where h is in terms of x. So I've gone this way to get h by itself, and I can simplify this now by splitting it up. I get 48 over 6x. I can split up if I have a single denominator, minus 4x squared over 6x. 48 and 6 cancel out to give me 8 over x, and 4 and 6 cancel out to give me 2 and 3, so 2x squared, they cancel out to just give me x there, 2x over 3. So h is equal to 8 over x minus 2x over 3, and there it is there, 8 over x minus 2x over 3. I've just worked my way progressively towards the thing that I'm asked to show in the question. Bit of algebra there, but really not too bad. Now express the volume, so we're now working on this step 3. Express the volume, which I should actually make a note. This is A, now this is B. The volume is equal to 2x times h, but we want the volume in terms of x. So I'll simplify this first. I get 2x squared h, but I know that h is equal to 8 over x minus 2x over 3, so therefore the volume will be equal to 2x squared times 8 over x minus 2x over 3, and that simplifies out quite nicely, reasonably nicely, to 16x, the x squared and the x cancel, minus 4x, well I might even write it like this, 4/3 x cubed. Which is nice because then in step 4, which just so also happens to be the start of part C, because we've now done part B, find the maximum volume. This is where we now bring in this calculus. dv dx is equal to 16 minus 4x squared, because the 3 and the 3 here cancel out. And I want to let dv dx equals 0, and so I get 16 minus 4x squared equals 0, which gives me 4x squared equals 16, x squared equals 4, x equals plus or minus 2, but it is an area, surface area type question, so it can't be negative 2, so I'm going to take 2 meters, and it's asked me to find the maximum volume. So I should just do the check first of all, and this is the check of the nature. So step 5, which is that d squared v dx squared is equal to negative 8x at x equals 2. d squared v dx squared is equal to negative 16, which is of course negative, and therefore it's a maximum, which is what we wanted. And of course, now we conclude back into the question. At x equals 2, volume is equal to 16 times 2 minus 4/3 times 2 cubed. And that's equal to 32 minus 32 over 3, which is 2/3 of 32, or 21 2/3 meters cubed. It is a volume, so that's meters cubed. And that occurs when x equals 2, and if you needed to know, we could work out h for x equals 2. It would be 4 minus 4/3, which would be 2 2/3 if we needed to. But in this case, it hasn't asked for h, it's asked for the volume. So there's how we do example 6. There it is there. To find the maximum volume by first finding h in terms of x and eliminating h, and then using calculus on the volume in terms of x to maximize. All the best.